Good morning, boys. Good morning, my dear. This is the last day for coordination compounds. So, in our textbook, there are some organometallic compounds. That is nothing but carbonyl complexes. Okay, let us discuss about the carbonyl compounds. How many types there? All those are very, very important. So, see here. Organometallic compounds and also complexes. Compounds also. What are these? See, my dear, organo means it is organic part. Metallic is nothing but there should be a metal. That means a compound or a complex, whatever it may be, having metal and organic. Organic is nothing but carbonated. Carbonated compounds chemistry is called as organic. That means that is from organic side carbon, from metal side M. There should be a bond between metal and carbon. It is nothing but carbon, my dear. There should be a bond between metal and carbon. The formed compounds or complexes are called as organometallic compounds or complexes. Okay, that means in these compounds, there is a direct bond between carbon atom and metal atom. Carbon atom and metal atom, the compounds are called as organometallic compounds. Okay, okay, now please respond.
Okay, sir.
Now, if this bond, depending on the type of bond between carbon and metal, these organometallic compounds are broadly divided into three types. What are those? If this bond is between metal and carbon bond is sigma bond, that is sigma bonded compounds. Sigma bonded compounds. Best examples, my dear. RMGX, alkyl magnesium halide, nothing but Grignard reagent. Am I correct? Grignard reagent.
Yes, sir. Yes.
Here, let us take alkyl group is CH3, magnesium with chlorine. Here is magnesium is a metal, my dear. From CH3, there is a carbon. There is a bond between metal and carbon. That is what I told just before. Here, the bond between metal and carbon is a sigma bond. Okay, that is why this is organometallic compound with a sigma bond between metal and carbon. That is sigma bonded compounds. Clearly understand or not?
Yes, sir. Understand.
Next, alkyl lithium. That is CH3Li. Alkyl lithium. Alkyl zinc. Zinc is metal, lithium is metal. Alkyl, that is from alkyl group, that is CH3 group should be there. Okay. So that means metal and carbon, there is a sigma bond. All these are examples to sigma bonded compounds. Sigma bonded compounds. Okay. So this is one type of organometallic compound. The first type is if metal carbon bond is a sigma bond, that is called as a sigma bonded compounds. Second one, an important one. All these are important, no doubt. Second one, between metal and carbon, the bond is a pi bond only. Only pi bonded electrons involved. Only pi bonded electrons are involved. Now, that is pi compounds, pi bonded compounds or complexes. That means, see here, platinum, Cl, my dear. Here, there is CH2 double bond CH2. Okay, it is alkene.
Yes, sir.
One is a sigma bond, one is pi bond. Okay, now this is sigma bond, this is pi bond, my dear. between carbon and carbon. Okay. So now this 5 bonded electrons can be donated by this ligand to the platinum. Okay, na? Clear?
Yes, sir. Yes, sir. Clear.
That means from the ligand, 5 bonded electrons are involved in complex formation. That is why this type of compounds are called as 5 bonded complexes. It is nothing but cisplatin. Cisplatin. It is the best example for 5 bonded compounds. Not only this, ferrocene. Do you know?
No, sir.
Ferrocene.
No.
It is sandwiched component. Ferrocene, sandwiched compound. See here. What is the name of this compound? Cyclopentadiene. Am I correct?
Yes, sir. Yes, sir. Yes, sir.
Now there is a lone pair with a negative charge. Okay. It is
Yes, sir.
cyclopentadienyl
Carbon ion.
ion. Dienyl ion. It is aromatic compound, my dear.
Yes, sir.
6 pi electrons, ring compounds, all are in the same phase. That is aromatic component. What is the name of this one? Cyclopentadienyl anion. Okay, now similar to one more. Same. Cyclopentadienyl anion. See, my dear, this bond, and this lone pair, all these are involved in resonance. Okay, now here Fe plus 2
Yes, sir.
exists. Fe plus 2 exists. This is the metal ion. All these three, there is a resonance. Here also there is a resonance. So this 5 bonded electrons donated to this Fe plus 2 ion. Okay, now tell me, what is the coordination number of Fe plus 2 here? Here 3 pi bonds, my dear. And that means 3 electron pairs. Here 3 pi bonds, 3 electron pairs. Total 6 pairs of electrons donated by 2 cyclopentadienyl anions. Okay, here Fe plus 2 has coordination number 6, but it seems to be two groups. Here 3 to 6, here 3 to 6. Totally 12 electrons donated by these two groups. Am I correct or wrong?
Yes, sir. Correct.
Yes. Now this compound is called as ferrocene. See, my dear, this Fe plus 2 is a sandwich between two cyclic groups.
Yes, sir.
These two cyclic groups. That's why it is taken as a sandwich compound. It is also considered, it seems to be sandwich, but it is a ferrocene. The most important example, it is 5 bonded electrons are involved in the bond formation, in the coordinate covalent bond formation. That is why this is called as 5 bonded complexes. Clear? That means 5 electrons are only donated
Yes,
by that particular ligand. See, my dear, while writing the name of this complex, so if cyclic groups are there, if 5 bonded electrons are involved, okay, eta is the letter used, and eta while writing the name. Eta, something power is given to you, my dear. That power is nothing but number of atoms in the ring. Number of atoms in the ring, or number of atoms between the pi bonds. For example, here these 3 pi bonds is surrounded with 5 carbon atoms. That is 5 carbons are there. That is eta power 5. I am writing it. Eta power 5. For example, previously in CH2 double bond CH2, that is cisplatin, there is this electron pair is donated. That means here how many electrons are there? 1 and 2. In this case, eta power 2 is used while writing the name.
Okay, sir.
Eta indicates that is the pi bonded complex. There, the pi bond between how many atoms? That is two atoms, and this indicates number of atoms in the pi bonded conditions. Okay, here also atoms.
Yes, sir.
Now, see, my dear, what is the name of this complex? This is cyclopentadienyl. So it is a cyclopentadienyl. It is also cyclopentadienyl. It is Fe. Overall, this is -1, this is -1, this is +2. It is neutral complex, and it is neutral complex. So two cyclopentadienyl groups are there. That is bis. Bis means two groups, and cyclo. Sorry. Bis eta power 5 cyclopentadienyl iron. So cation iron, its oxidation state is 2 and iron 2 complex. Iron 2 complex. Cyclopentadienyl. My dear boys, negative ligands names are ended with ATE. Am I correct or not? Oh, that is Cl minus is there. Chlorate, chlorito, chloro. That is name is ended
Yes,
with
sir.
O. Chloro, bromo, bromido, like that. That is why here also it is negative ligand. Cyclopentadienylato. Okay, na? Name is enylato. Iron 2. It is the name of this compound. Clear? Enylato. Because this is
Yes, sir.
negative ligand names are ended with O. Bond, cyclopent. So that means here it is only sigma bond electrons are involved. That is, it is called as a sigma bonded complexes. Like this, number of examples are there in your textbook. Please see once again at the end of complex compounds, at the end of coordination compounds. Last but one pages are there. Okay, it
Okay,
is
sir.
the second type. That means between metal and carbon, there is a sigma bond. That is a sigma bonded compounds. If metal and carbon, there is a pi bonded electrons are involved. That is, it is a pi bonded compounds. It is RMGX is the best example. Alkyl lithium is the example. Alkyl zinc is the example. All these are the examples for this type sigma bonded compounds. It is cisplatin is the example. This ferrocene is also one of the examples. So this is only pi bonded, but there is another type, and between metal, that is a type 3, my dear. Between metal and ligand, okay, here the bond is both sigma and pi bonds. Two bonds are there. Both sigma and pi bond, both are available. That type of compounds are called as sigma pi bonded compounds. Sigma pi bonded complexes. The best example for this one is carbonyl complexes. Carbonyl complexes are the best examples. This is the third type, and also important. Carbonyl complexes are the examples for sigma pi bonded compound. That means between metal and ligand, both sigma bond and pi bond are exist. Both sigma bond and pi bond are existent. See what happened. Let us take a carbonyl complex. sigma and pi bonded complexes. Let us take an example, that is NiCO4, nickel tetracarbonate, FeCO5, iron tetracarbonate. Like this going on, my dear. Number of examples are available. Okay.
Okay, sir.
Mn2CO10. Mn2CO10. This is also available. Okay. Here also in all these cases, metal with carbon monoxide N times. Those complexes are nothing but carbonyl complexes. Metal and carbon monoxide, the combination, the complexes are called as carbonyl complexes. Okay. Between metal
Okay, sir.
and carbon of carbon monoxide, there is two bonds. One is sigma bond, one is pi bond. Okay, now next. So here among these two bonds, that is from carbon monoxide, from carbon of carbon monoxide, that is first of all an electron pair donated to metal atom that first can form sigma bond. After that, the lone pair present in metal atom can also donate another bond, that lone pair to the carbon monoxide. That means here two bonds are there, one from carbon to metal, another one from metal to carbon. This is a coordinate covalent bond, no doubt. It is also coordinate covalent bond, but it is pi bonded. This bond is called as synergic bond. That is compensated bond. Synergic bond. Actually, what we expected between metal and ligand, only we can expect sigma bond from ligand to metal. Am I correct or wrong?
Yes, sir. Correct.
This is actually we expected. But in here, metal also donates an electron pair to ligand. That is why one is sigma bond, another one is pi bond. That is why this type of compounds are called as sigma pi bonded compounds. This type of bonds. This is happening only in case of if ligand is carbon monoxide. If ligand is carbon monoxide, then only this type of bonds are exist. That is why carbonyl complexes are sigma pi bonded complexes. That is why carbonyl complexes are sigma pi bonded complexes. So why, sir? Why this is happening? See here. In MO diagram of carbon monoxide, MOT of carbon monoxide, how many electrons are here? Carbon 6, oxygen 8, a total 6 plus 12 electrons, sorry, 14 electrons. That means less than or equal to 14 electron system here. It follows N2 diagram. Am I correct or wrong?
Yes, sir. Correct.
MOT, N2 diagram. N2 diagram is 1, 1, 1, 1, N2, 2, 2, 1, 2,
Sir,
2,
2,
1.
1, 2, 1, sir.
Okay, now it is N2 diagram.
Yes, sir.
14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is sigma 1s, it is sigma star 1s, it is sigma 2s, it is sigma star 2s, it is pi 2 px, it is pi 2 py, it is sigma 2 pz, it is pi star 2 px, pi star 2 py, sigma star 2 pz. These are the orbitals, my dear. Am I correct? Now, in MO diagram of carbon monoxide, these orbitals are empty in situation. Correct or wrong? Pi star antibonding orbitals. Pi
Yes, sir.
star antibonding orbitals of carbon monoxide are empty. Correct, na? Is this correct or wrong?
Yes, sir.
Pi
Because,
star,
sir, it is
all
less
these
than
are
that.
paid up. All these are paid up.
Yes, sir.
The empty orbitals are this one. That means if carbon monoxide accept any electron pair from others, so that can be filled by, that can be filled with in pi star orbitals. These pi star orbitals are homo orbitals or lumo orbitals, occupied orbitals or unoccupied orbitals. First of all, these
Sir, unoccupied.
unoccupied, that is lumo, lowest unoccupied molecular orbital set. Lowest
Yes,
unoccupied
sir.
molecular orbitals. Okay, that is LUMO orbitals are filled in. What are those LUMO orbitals in this case? That is a pi star antibonding orbital site of carbon monoxide. That means there is a vacancy
Yes,
in
sir.
carbon monoxide also. There are certain empty orbitals in carbon monoxide also. Okay. So next, if metal, my dear point, I am taking NiCO4 for an explanation. Nickel, atomic number 28. Atomic number 28 means S2D8. That is 4s2 3D8. In carbonyl complexes, oxygen state of metal is 0. Okay, na? So that means, so no electron is lost. It is a 3D8. 3D. It is 4s. It is 4p. So 1, 2, 3, 4, 5, 6, 7, 8. D8. Yes, 2. Carbon monoxide is the strongest ligand. Am I correct? As per our CFT, carbon monoxide is the strongest ligand. It is carbon donor
Yes, sir.
ligand. Okay, because of that, these two electrons are also jumping from there to here. And now D5 configuration is there. That is, all those D orbitals are completely filled and S orbital is empty. That is why it is sp3 hybridized. sp3 hybridized. Now, nickel tetracarbonyl is an example to a tetrahedral complex set. Nickel tetracarbonyl is tetrahedral complex, that is sp3 hybridized one. Okay, now see, my dear, in nickel, these are the electron pairs which are available in metal, which are not involved in bond formation. Am I correct or not? No. These are all considered as lone paired electrons. Correct? Na? All these are lone paired electrons or not? In nickel,
Yes, sir.
these are non-bonded electron pairs. Correct or wrong? These are non-bonded electron pairs
Correct, sir.
which are not. Okay. Now, in nickel carbonyls, Ni, let us see here. Ni, carbon monoxide, carbon monoxide, carbon monoxide, carbon monoxide, my dear. It is actually happening just like our previous complexes. But nickel has lone pairs. How many lone pairs? 5 lone pairs are there.
5 lone.
Okay. Nickel has 5 lone pairs. Carbon monoxide also has empty atoms. These are the empty atoms. Correct or wrong? Okay, now, because of that,
Yes,
this
sir.
nickel, lone pair of this nickel donated to that electron pair to carbon because there is electronic repulsions that exist. Because of repulsions, nickel can also donate that electron pair to the carbon monoxide. Because of that, this is sigma bond, it is a pi bonded and it is a synergic bond. That is synergic bond. That means that is back bonding. And actually, we are discussing that nothing but back bonding. And this is happening. This is involved
Yes,
in
sir.
resonance. Sometimes this one, sometimes this one, sometimes this one. Because of that, here the metal ligand bond is strengthened or weakened. Because single bond is
Strengthened, sir.
converted into double bond.
Very much strengthened.
Strengthened. That means because of this bond, synergic bond, and because of the synergic bond, so actually metal ligand bond is a sigma single bond. Because of synergic bond, metal ligand bond is double bond character. That means between metal and ligand, bond order increased or not?
Yes, sir.
Bond order increases means bond length decreases. Next, bond energy increases. Because number of bonds increases, bond energy also increases between metal and ligand. That means as synergic bond strength increases, easy to form. When synergic bond is easy, if number of lone pairs at the
Yes,
metal
sir.
is more, repulsions are more, that back bond formation is more. Correct or wrong? If number of
Sir, can
lone
you repeat, sir?
pairs, if number of lone pairs in metal is more, repulsion between those lone pairs is more.
Yes,
Because
sir.
of lone pair repulsion is more, that back bond formation is more easy to
Yes,
form.
sir. Yes, sir.
Okay.
Correct,
As
sir.
the number
Yes,
of lone pairs in metal increases, as the number of lone pairs at metal increases, synergic bond easy to form. Correct or wrong?
correct, sir.
Okay, now automatically, my dear, actually between carbon and in carbon monoxide, there is a triple bond between carbon and oxygen. But because of synergic bond, the triple bond converts into double bond. That means, see here, metal, carbon monoxide, my dear. It is without synergic bonds. Here, between metal and carbon, bond order is equal to 1. Between carbon and oxygen, bond order is equal to 2. Sorry, 3. Okay, it is actually. But if synergic bond is there, metal, carbon always can form how many bonds, my dear? 4 bonds or 5 bonds?
Sir,
Carbon can form how many bonds?
sir, 4.
4. Already it has 3 and it is 1. Total 4 bonds accepted. Actual original case. But if synergic bond is happening, if synergic bond is taking place, so the bond order between metal and carbon increases. Automatically, the bond order between carbon and oxygen decreases. Okay, it is with the synergic bond only. With the synergic bond, correct or wrong? So automatically here, bond order is equal to 2. Here also bond order is equal to 2. Due to synergic bonds, metal ligand bond order, what happening? Increased or decreased? Metal ligands
Increases, sir.
increases. That is carbon and oxygen bond order
Decreases.
decreases. So bond order increases means bond length decreases, correct? Bond length. Next, bond
Yes,
order
sir.
increases means bond energy also decreases. Sorry, bond energy increases. Because more bonds, more is the energy required to break the bonds. Here, between carbon and oxygen, bond order decreases, bond energy decreases, bond length increases. These are the number of questions, different variety of questions asked in your carbonyl complex system. Where more synergic bond is there these happening. When synergic bond is more, so that was depending on the lone pairs at the metal atom. More lone pairs at the metal atom, more is the synergic condition. More is the synergic condition, more of these are the important situations. These are the important situations. Clear?
Yes, sir.
Yes, sir.
Okay. Now, my dear, see here. These carbonyl complexes always try to follow EAN rule. Always try to follow EAN rule. Okay, EAN already I told to you at the beginning of
Yes,
this
sir.
topic,
Effective atomic
this
number.
complex compounds. Yes. So every carbonyl complex try to follow EAN condition, either by losing electrons or by gaining electrons, whatever it will be, or by doubling. That is dimerization, trimerization may also available. Because of that, metal bonds may also availability, may also form because for formation of a stable complex. That means that for following EAN concept, to follow EAN rule, see here, for example, what is that? VCO5, my dear. Is this follow EAN rule or not? EAN. How to calculate EAN? EAN is nothing but
Does not.
atomic number of metal minus oxidation state plus 2 into coordination number. Okay. Now, atomic number of metal: scandium, titanium, vanadium. Vanadium atomic number
23.
23. Oxidation state 0 plus 2 into coordination number 5.
Five.
So it is 23 plus 10, that is 33. Okay, na?
Got it.
Okay. So it is not equal
Yes.
to 36 krypton atomic number. Am I correct?
Yes, sir.
Is this follow EAN or not?
Does not, sir.
Does not. But no doubt every carbonyl complex must follow EAN. For that purpose, it may lose electrons or it may gain electrons. Okay. From others. That means here this complex converts into CvCO5, or it is better to take CO6 by there. If it is 6, it is 6 times. It is 6 times. It is 12. 12 means 35. Okay, na? We were 6. I'm taking that example. Okay, but it doesn't follow EAN. For that, it gains one electron from others. Now VCO 6 times converts into VCO minus 1. That means because of minus 1, one more electron is added here. That is a 35 plus 1, 36. Now it becomes 36. It follows krypton atomic number. Now, in this case, vanadium follows EAN or not?
Yes, sir. Follow.
Follows. Okay, because of this. See, my dear, every every carbonyl complex always follows EAN. Always follows EAN, no doubt at all. Either by losing electron or by gaining electron, whatever it may be. Here, what is the oxidation state of vanadium? Here, oxidation state of vanadium is minus 1.
Minus 1.
That means vanadium is changed to vanadium minus 1. Okay, here I have vanadium, it is converted to vanadium minus 1. Here, oxidation state of vanadium increased or decreased? Decrease. Okay,
Reduction.
so it is by the gaining of electron. Now, so 0 to minus 1, it is reduced. Therefore, vanadium acts as oxidizing agent. Okay, now this complex acts as, in this complex, vanadium acts as oxidizing agent by gaining electron to get stable conditions. Clear or not?
Yes, sir. Clear.
Okay, see, my dear, MnCO5. This is the complex, my dear. Is this manganese follows EAN rule or not? Manganese, how much it is? 25
25.
minus
Does
0
not, sir.
plus 5 into 5. Sorry, 5 into 2. 2 into 5. That is 35. Follows EAN or not? Not follows.
Not follow.
That is not 30, 36. But, see, my dear, manganese, CO, 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 5 types. Manganese, CO, 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 5 times. Here manganese is in 35. Here manganese also in 35. If there is a bond between these two, that is metal-metal bond exists, that bond also added to here. Now it becomes 36. Correct or not? Without Mn bond, that should be 35 only. If there is a bond
Yes,
between
sir.
metal Mn and M, that is metal bond also added there, that it becomes 36. That means between Mn and Mn, there is a metal bond is there or not?
It is this.
It is there. So that means in which of the following complexes metal bond exists? So at that time we identify EAN. If EAN is not equal to nearest inert gas concentration, atomic number, not equal to, then there should be a metal bond available, possible. That means here it is dimerized. Am I correct? It is Mn2 CO 10 times N. Now overall it is not MnCO5, it is Mn2 CO10. Okay, that means this complex is a dimerized because of formation of metal bond. Why this is happening? To reach octet concentration. Sorry, to reach inert gas concentration. That means there is existence of metal bond is also explained on the basis of EAN. Existence of metal bond is also explained on the basis of EAN. If EAN is not equal to nearest inert gas atomic number, if EAN is not equal to nearest inert gas atomic number, automatically in that carbonyl, my dear, all these applicable only for carbonyl complexes. In that carbonyl complexes, metal bond is there. In that carbonyl complexes, metal-metal bond is there, no doubt at all. Okay. Understand or not?
Yes, sir.
See,
Understand.
my dear, actually, metals don't have any negative oxygen states. Metals don't have any negative oxygen state. Metals always exhibit positive oxygen state. But in carbonyl complexes, metal may also gains electrons, may also lose electrons. Okay, so that is why metal sometimes positive oxygen state, metal sometimes negative oxygen state also possible. Already we wrote here, vanadium has minus oxygen state. Actually, metal don't have any negative oxygen states, but here metal has negative oxygen state. Okay, na?
Okay, sir.
So because of that, this complex acts as oxidizing agent. For example, if metal loses electrons to get to get net gas configuration, if it loses electrons, it acts as reducing agent. Because here it is against electron, it acts as oxidizing agent. There, if electron is lost by the metal, that is reducing agent. That means carbonyl complexes sometimes acts as oxidizing agents, sometimes acts as reducing agent, sometimes not oxidizing agent, not reducing agents. Like that, everything is happening. Clear?
Yes, sir. Clear.
Understand?
Yes, sir.
Okay, my dear. This is the end of coordination compounds. But you should read your NCRT textbook. At last, there are some uses of carbonyl complexes. There are complex compounds. Applications of complex compounds. At the last, open your NCRT book if you have. And
Yes,
the
sir.
last,
Open, sir.
cisplatin, use it to treat
Cancer drugs,
cancers.
sir.
Yes. Okay. Everyone, last sentences are there. You should write, you should note down each and every line of that NCRT book. Every
Okay,
line, every application is very, very, very important. Okay. So finally, this is the end of coordination compounds.